Let's study concrete. Concrete is a composite, man-made stone. It consists of a rationally chosen mixture of binding materials such as cement, it should be 10% of the total volume, well-graded fine and coarse aggregates, it should be 75% of the total volume, and water, 15%. There can be admixtures less than 2%. If concrete is poured with reinforcing materials, a different product called reinforced concrete will be yielded. Aggregate consists of coarse, generally a coarse gravel or crushed limestone or granite, along with fine sand particles. The size distribution of the aggregate determines how much binder is required. Aggregate with a very even size distribution has the biggest gaps, whereas adding aggregate with smaller particles tends to fill these gaps. The binder must fill the gaps between aggregate as well as pasting the surface of aggregate together and is typically the most expensive ingredient. Thus, variation in size of aggregates reduces the costs. The aggregate is nearly always stronger than the binder, so its use does not negatively affect the strength of concrete. Cement, most commonly Portland cement, is the main binder. To produce concrete, water is mixed with dry ingredients, which produces a semi-liquid slurry, a paste or matrix, which in addition to filling the voids of the fine aggregate, coats the surface of fine and coarse aggregates and binds them together. And this matrix can be shaped, typically by pouring it into a form or mold. A lower water-to-cement ratio yields a stronger, more durable concrete, whereas more water gives a free-flowing concrete. Impure water used to make concrete can cause problems when setting or causing premature failure of the structure. Hydration involves many different reactions, often occurring at the same time. As the reaction proceeds, the products of cement hydration process gradually bond together the individual fine and coarse aggregate particles to form a solid mass.